everyone, welcome to the 7th video of Module 4, and here we are going to learn about Matplotlib library. Specifically, we are going to talk about PyPlot module over here and create our first visualization by creating some of the data by using NumPy methods that we have learned so far. So let's get into it. I guess this much amount of NumPy is going to be enough for whatever the things we'll be dealing with the upcoming few modules. Now it's time to deal with Matplotlib. And now you're going to see how you can convert this kind of a data into visualizations and then how you can customize it. Okay, it's very important thing when it comes to creating some kind of visualizations from your numerical data. So it's the sixth thing that we are learning over here. That is, create the first visualization using matplotlib.pyplot. Right? So how can we do this? So what I really want to do is I want to create a graph. I want to create a line plot actually. That's going to be like a quadratic curve. Okay, create a line plot of a quadratic curve. And how can I get this done? For this, first of all, what I'm going to do is I'm going to generate some set of inputs. Okay, let's say for example, it's going to go in between -10 to 10, something like that. Okay, so I'll create some bunch of values I want to plot on the x-axis, that is independent. Okay, so for that I can use linspace. Okay, because I know that linspace can give me numbers in between two values, and then as many values I want in between them, I can simply generate that. So np.linspace, let's say I'm choosing -10 to 10, but let's say some 10 different values in between them. All right, so let me just go ahead and also print this thing, print x, and see what happens. So these are the bunch of values that I'm going to give as an input, and then I'm going to square this kind of numbers, and then it's going to give me that kind of a quadratic looking like output. Okay, so what I'm going to do is I'm going to generate my y that I'm going to plot on my y-axis. I'm going to say that I'm going to just square all the values inside the x. So I go ahead and do this. I'm getting this output of y as this. Okay, these are the bunch of numbers. If I print both x and y together to show it to you, you can see that -10 square is 100, 10 square is 100, then all the respective squares is the output that you are having over here. Now that's the power of using NumPy arrays. If I have to do this with list, just think about it. For example, if I'm doing 1, 2, 3, and if I square it, it's not even going to work. Okay, let me just do it properly. It's going to give you an error. You cannot have this kind of a power of 2 for this list. You need to convert this into NumPy array for that to work. Okay, np.array. And that's why we deal with mathematical operations over here very easily and smoothly. You can see that now this array has given you the output of this in the format of square. I can simply go ahead and print this. It's going to look like, it's just a list, but it's actually an array, right? That's the major difference between a list and an array that I really wanted to show you all. But yes, guys, this is the x and y data that we have created. Now, I'll actually go ahead and just cut this part and say that create a data to plot, to create a data to generate a line plot. And now I'm going to say that create a line plot of a quadratic curve from the above data, using the above data. All right, how can I do this? I know that because I'm trying to create a visualization now, I need to use what? I need to use matplotlib.pyplot. And to use that functionality, I simply use this plt. I'll come down over here and mention this plt.what? plt.plot. This plt.plot is going to give you a line plot. Just like this, let's say if you want to create a scatter plot, I can use plt.scatter. If I want to create a box plot, I can use plt.boxplot. If I want bar plot, I can do plt.bar. Whatever is the respective functionality that we have inside the pyplot, right? So for now, because I want to create a line plot, I'll use plot because that's how we are going to create a line plot. On x-axis, I'll be giving x. On y-axis, I'll be giving y values. And to display it over here, I'll say plt.show. Let's see what happens. I'm going to run this code and let's just wait for it to run. Typically, it does not take this much amount of time, but yeah, this is the output that we got. It's not really looking quadratic. It's a sharp turns that we can see over here. There is no smooth curve. The reason behind this is because we are having very small amount of values in the X. Let me just change it to, let's say, 500, for example. And now if I run this code, it should give you a smooth looking output. See, it's a smooth curve now. More the values, smoother the outputs you will be starting to get in the output. Now let's say if I'm not really comfortable with this large looking outputs, I can also customize this type of functions. I mean, not functions, but the graphs. How can I do this is something that I'll be showing you in the upcoming video. But yes, guys, this is how you can take any type of data. You just need to have this X, you need to have some Y, pass it into whatever functionality you want to use, and just create this kind of visualizations. For example, just to show the scatter plot, I'll just change it to, let's say, 5 points only. And instead of this plot, I'm using scatter. You will see that it's going to give me this random points, in the format of this kind of a quadratic nature. 1, 2, 3, 4, 5. So there were 5 different values in the X, and its respective output over here is what I'm getting on the Y. So when my X was -10, you can see the output is 100. When my X was 10, the output is 100. In between them, there are 3 more values and its respective outputs are over here, as you can see. So this is called a scatter plot. If I, let's say, for example, change this 5 to 15, it will be using the 15 values in between -10 to 10, which are equidistant. And that's the power of, that's the reason why we had used linspace. It automatically generates equidistant data for us. That's what we can use to plot it over here. Isn't it looking just great? Trust me, guys, it's going to look even better when we start doing the customizations on top of this. All right. But let me just for now convert this into line plot, and also just, let's say, change this to 150, for example. Yes, this is where we started with, right? So yes, let's just go ahead and now customize this particular thing in the next video. Alright guys, so that's the end of the video over here, and I hope that it was useful in order to create your first visualization. Now in the upcoming video, you will be seeing that how you can customize it and make it look much more beautiful as compared to what it is right now. So I'll see you in that next video.